Hello, and thanks for taking the time to learn about bees with me. My name is Megan Milbrath, and I've been a beekeeper for almost 25 years, and I work in honeybee extension and research at Michigan State University. As part of my job, I get calls from beekeepers asking questions or seeking help with their bees. In the winter and early spring, unfortunately, many of these calls are beekeepers asking why their bees died. Because I talk to so many beekeepers, I can start to see some patterns emerging. In 2016, after talking with dozens of beekeepers who all saw the same thing, I wrote an article that outlined the most common type of bee death that we were seeing. I'm recording this video in the spring of 2018, which is 2 years later, and the story appears to be exactly the same. Over the last few years, many beekeepers are losing their bees for the same reasons. In this video, I'll go over the most common cause of winter honeybee colony loss among small-scale beekeepers. We'll cover how to identify potential causes of death and what you can do with the equipment from your dead hives. This is the first video in a series of 3. In the other 2, I'll cover what you can do to help keep your bees healthy and alive in the upcoming years. There is nothing worse than going out to your hive in the winter or early spring and seeing something like this. We hope to open a hive and hear happy buzzing and see signs of life, and instead we're met with quiet, sad, and gross. It is a really disheartening experience. Rather than have a strong, healthy colonies to split and thrive and make lots of honey this season, we have to clean up disgusting equipment, spend more money on packages, and deal with the knowledge that we failed to keep our bees safe and healthy. In Michigan, like much of the country, the winter of 2017 and 2018 was exceptionally cold. I don't know the official accounts for losses in my state or around the country yet, but I know that I've had a lot more calls from beekeepers who lost all or most of their bees this year. Many of them cite the cold as the cause of death of their colony. While cold temperatures are more stressful in a colony, honeybees can survive just fine in the cold. It wasn't the cold that killed your bees. As humans, when we think of winter cold, we want to bundle up and get inside by a warm fire. We would die if we were left outside in a box in conditions like these. However, just because we humans are kind of wimpy, that doesn't mean that animals are. Most of you have seen the documentaries about how the emperor penguins survive Antarctic winters. They go into a cluster, with the outside penguins standing tightly together, with their faces towards the middle. The birds inside are warm and they can move all around. After time, the cluster shifts. The cold penguins on the outside move to the middle to warm up, and the warm birds take a turn acting as insulation. Our bees do a very similar thing when the weather turns cold. They form a winter cluster, with bees on the outside forming a tight insulating layer with warm bees in the middle. A big cluster can find food easily. They can move like a blob, shifting the shape to reach more food stores. The bees will form this cluster whenever the weather is cold enough. When it's warm, they break cluster and can move around the hive. If it's really cold, the bees in the middle will start to vibrate their muscles to create warmth. This figure represents the amount of energy used by the colony at each temperature. We can see that the colony is the most efficient when it's in a cluster right around 45 degrees Fahrenheit. As we move to the left and temperatures get colder, we can see that the energy needs go up as the bees start to move their muscles for warmth. This is more work, but as long as the bees have enough food to sustain this work and the ventilation to remove the resulting moisture and CO2, the bees can sustain really cold temperatures, well below zero. The dense insulating mantle of the honeybee cluster is very efficient. It has the insulating capacity much like down or warm fur. Plenty of small animals can handle cold winters as long as they are in good health, have ample food, and good insulation. Our bees know how to create the insulation. Our job as beekeepers is to provide our animals with the sufficient food and to keep them in good health. And the key phrase here is in good health. So if it wasn't the cold, why did my bees die in winter? A healthy honeybee colony can survive the cold, as long as it has enough food and is big enough to have a functioning winter cluster. The issue is not so much that we had a cold winter, but that beekeepers tried to get colonies that were weak and unhealthy through the winter. In milder winters, sometimes these weaker colonies can eke through. In a tough winter, only the strong survive. And now you'll say to me, but my colony looks so good this fall. And here's where a lot of beekeepers get caught. When you see a colony that is big and booming in the fall or late summer, you're seeing a lot of bees that were raised over the last few months. Even in healthy colonies, these bees will die off as the winter progresses. The only bees that will determine if our colony will survive until spring are the winter bees. These special bees have different fat deposits, different hormone profiles, and are the only ones designed to live for months. They're the last few generations that were raised in the fall. If these bees were infected with viruses, then they will be weakened and unable to handle the stress of winter, or to form a strong winter cluster. Unfortunately, colonies that were big and booming over the summer are most at risk to have viruses in their winter bees. Here's a figure that explains why. This graph is from Randy Oliver, whose website scientificbeekeeping.com is really useful for learning more about varroa dynamics. The yellow line represents your bee population that grows over the summer. The red line is the varroa population, which also grows over the summer. Since varroa use the bee brood to reproduce, the more bees you have, the more varroa you'll have. We'll discuss this relationship in the next two videos, but the main point is that varroa populations peak right as your winter bees are getting made, and when you still have lots of summer bees in the hive. So it's really common that you would open your hive at this time, see lots of healthy looking adults, but not realize that the developing pupa are becoming highly infested with viruses. But I didn't see any varroa, you'll reply. Well, maybe not, but that has a lot more to do with how tricky varroa are than how healthy your colony was. In the next video, we'll cover the tools to see how many varroa in your hive. Now, in the next few slides, we'll show you how to autopsy a hive and determine if varroa-associated viruses are the main suspect. As we just discussed, the big healthy colonies are most at risk. Smaller colonies that didn't have a lot of brood or that swarmed a lot will actually have fewer mites. Whenever the bees raise a lot of brood, the mites can also raise a lot of young. Some beginner beekeepers actually have better survival because they make beginner mistakes that restrict brood rearing. For example, as a first-year beekeeper, you may not have had an issue with mites if the colony grew too slowly, or maybe you damaged the queen and the bees had to supersede her. Maybe in the second year you forgot to put supers on in time, and the bees filled the brood nest with nectar or swarmed. This would have stopped varroa growth. In your third year, you finally got it together in terms of supering, you ended up with a big booming colony, and finally got some honey. Well, these are the colonies that we're going to worry about the most. Once I had a teaching colony that had mild shock brood infection. They never got very big, they never made much honey, but they always survived and they never had problems with varroa. So, the first clue in our autopsy list that points to varroa as a culprit is that the colony was big in the fall. Hopefully our notes will tell us if the colony was big last fall, but if not, we can still learn by looking at the hive. Here's a colony that was unmanaged and died from varroa. As you can see, there was once a big cluster, indicated by the dark comb showing a big brood nest. This is up in the second box. And then the big patch of honey that was eaten away from a big cluster. The second clue pointing to varroa is that there's a lot of honey left in the hive. This is for a few reasons. First, it's a sign that starvation wasn't the issue. We do lose colonies to starvation in the winter, but if you had to lift off heavy boxes that are still filled with honey, you could pretty much guess that wasn't the case. Second, it wasn't suffering from a summer disease. Lots of honey indicate that the colony was big enough to make a lot of honey, so it probably wasn't sick with any of the diseases that are more likely found in the summer. Remember my colony with jock brood? Never built up a lot of honey because the disease kept it consistently weak. Similarly, if you had a disease like American fall brood, it would likely affect them all summer, and you would see signs of it during the year, and they wouldn't be bringing in boxes of honey. Finally, if there's a lot of honey left over, it means that most or all the bees died early in the winter. Remember that only the winter bees are the ones that can make it to the spring. If we had a good cluster of winter bees, they would use up a lot of honey as they kept themselves warm. If the winter bees have viruses, they die pretty quickly once winter stress sets in, and they don't use up the food stores. This can be tricky if your colony got robbed. Many colonies that died early could get robbed out, and you wouldn't see this clue. Note the jagged edges on this comb that indicate that it was robbed out. The third clue that varroa-associated viruses could be the culprit is a tiny cluster. In this photo, you can see a tiny cluster was all that's left of the colony. This is really typical of a colony lost to viruses. After the summer bees died off, there just weren't enough healthy winter bees to make a functioning cluster. There are a few other interesting things of this photo as well. See the bluish mold on the bees? You may think that the mold killed the bees, or that the mold means that there was too much moisture in your hive, and that's what killed the bees. The likely scenario is that the mold grew on the bees after the colony died. The second interesting feature in this photo is that all of the dead brood behind the bees. We can see that it's spread over a large area, indicating a large brood nest, and we can see that it's spotty, indicating signs of diseased winter bees. The last few generations were likely suffering severely from viruses, and many bees didn't emerge. You may see some spotting in the hive. Many beekeepers automatically assume that this spotting means the bees died of nosema. This may not be the case. Spotting just means that the bees had to poop, and they couldn't get outside to do it. The reason that they have to go could be nosema, but it could also be viruses or a patch of bad food. Small clusters are often found with some bee feces nearby, because the bees simply couldn't get warm enough to fly out to go. Here's another classic tiny group of dead bees, likely caused by viruses. There's no way these girls could form a good insulating barrier in a winter cluster. There are other diseases that can kill bees in winter, but they are way less common than the Varroa-associated viruses right now, and they present a little differently. So both nosema and tracheal mites affect colonies in the spring. With both of these diseases, the colonies are usually big in the spring and then dwindle quickly. With tracheal mites, you often see bees all over the hive or trembling out front. With nosema, you often see spotting, and the colony would have been bigger until just recently. If you suspect either one of those diseases, you should get them tested or check with a microscope to confirm before you rule out viruses as the potential cause. This leads to our fourth clue that indicates viruses. There's just not many bees left in the hive. If a colony dies from starvation or pesticides, usually there are loads and loads of bees on the bottom board. With viruses, most of the bees leave to die outside the hive. There may be a few handful of bees on the bottom board, but not a full colony's worth. You may see some varroa on the bottom board as well, but we often can't do a post-mortem bottom board count to understand the varroa risk in the fall. If the colony was too heavily infected, they may have left even before winter began. If the conditions in the hive are too poor, where a very small percentage of the brood are able to emerge in good health, then the whole colony may just up and abscond. You may think that your hive died because it swarmed in the fall and that your bees were just too dumb to realize that wasn't a good time. What likely happened is that your bees up and left because it was so diseased. You may have had some bees left in the hive, as you'll have some foragers that were out foraging and some nurse bees that were too young to fly at the time the colony absconded. These poor girls that missed the boat may still try to raise an emergency queen, but the resulting colony is not going to stand a chance in winter. Another classic sign of viral-associated death is that you'll see some patchy brood. Often capped cells, some with bees with their tongues out. In a healthy colony, they slowly shut down the brood reign in the fall, and then they slowly start up again in the spring. You wouldn't see patchy brood like in the photo above. Spotty brood indicate that some of the bees were too diseased to emerge in the fall at the right time, likely because they were infected with viruses. This was a research colony that had terribly high mite counts, so we know what was going on with it in the fall. Note the bee who died just as she was emerging. You can also see some cappings with holes in them. Many beekeepers may see this and worry that it's American fall brood, because they have heard of the sign of pupal tongue. This is not the tongue of a pupa, but of an adult bee. This is what the pupal tongue looks like with American fall brood. Note that in this photo, there's no head. In both cases, the hive is dead, but knowing what caused the death will be useful in knowing what you can do with the equipment. Even if you didn't see a lot of varroa on the bottom board or on your bees while they were alive, we can tell if they've been there. If you look closely at the cells around the brood nest, you should be able to see little white crystals. This is guanic acid that's expelled in varroa pee. The waste left over from the varroa mite is left on the sides of the cells. To view this, the best way is to keep the sun over your shoulder and to hold the frame with the top bar facing towards you, as shown in this photo. We want to look for crystals in the brood nest. So in this photo, we can actually see some white crystals near the colony, but that's actually crystallized sugar from unripened honey. That's not what we're looking for. This photo shows it better. Look at how many of these cells have the little varroa toilets. That means that all of these poor little pupae that were trying to develop in them were damaged and likely infected from mites while they were developing. All right, to review, signs that a colony likely died of varroa-associated viruses include the colony was big and looked healthy in the fall. A lot of honey was left in the top supers, if they weren't already robbed out. The cluster is small, maybe the size of a softball now. There are hardly any bees on the bottom board compared to a colony that, for example, starved. There's a patch of spotty brood, and some of that brood could be fully capped, some could have holes in the capping, some could have bees dying right on emergence. And then if you look closely in the cells around the brood, you'll see the white crystals stuck to the cell walls, showing the varroa waste. However, the most important sign that you likely lost the colony to varroa-associated viruses is that you don't have records that varroa was under control. And note that I didn't say whether or not you treated. As we'll cover in the management section, applying a treatment is very different from ensuring that a colony is safe and free from disease. You want to be confident that the bees that you are bringing into winter are free from parasites and are in good health. The Varroa virus epidemic is so bad right now that you can almost guarantee that you can lose colonies in this manner unless you take the health of your bees seriously. This is considered a preventable death. Of course, honeybees can die for other reasons. Colonies can starve, they can die in the spring from tracheal mites and nosema, and they can even get eaten by pygmy shrews, which I have had happen. We can still see issues like hives tipping over, bears, and the occasional lost queen. These types of death generally result in beekeepers losing 10 to 15% of their colonies over the winter. The viruses seem to be the ones that cause people to lose 50 to 100% of the colonies multiple years in a row. Unless you're having a huge pygmy shrew invasion, in which case you should probably invest in some better mouse guards, working on keeping your bees safe from Varroa will be the biggest change that you can do to improve your wintertime survival success right now. Let this year be the year that your bees stay healthy and are strong in the spring. The good thing is that as a beekeeper, you have the power to keep your bees safe from the Varroa mite. While it is a terrible pain to deal with this pest, it is a manageable disease. If you think that you lost your colony to Varroa, you can feel sad for a little bit, but then use this experience to understand how important it is to keep this deadly parasite under control. This year, you can make it a priority that you will protect your winter bees. One nice thing about losing a colony to Varroa is that it's preventable, so you know you can make some changes next year. If it was just the cold, we would really be in trouble because we can't change the weather. The other silver lining is that we can reuse the equipment. The only thing I like about Varroa is that the mites die when the bees die, so you don't have to worry about zombie mites coming out of your equipment to infect a new colony. It will be safe to reuse your equipment for your new package or your split. Varroa transmit vetting viruses, and that's ultimately what kills the bees, so we want to make sure that we aren't putting our bees onto highly pathogenic combs. Honestly, we don't know what happens to most of the viruses on the comb, and we're still learning. We do know that deformed wing virus seems to last about a month on comb, which means that if your bees died in early winter and your equipment sat out for a couple months, they'll likely be fine by the time you install your packages. We also know that most of the viruses seem only to be a problem when they are injected directly into the bee from the mites, not when the bees pick them up off the comb. So since this year you're going to be managing the Varroa, any remaining viruses likely shouldn't be a problem. It isn't a bad idea, though, to clean up the hive a little bit. You can dump out excess bees and toss the frames that are incredibly moldy, that have dead brood in them, or are filled with old pollen. It's a good idea to cull some frames every year anyway, so they don't build up on chemicals over the years. These frames may be just fine after a light scraping on the top. If the wax is black or there's dead brood, I may switch them out, but if the comb is good, they'd be fine to reuse after very little effort. If you have a lot of honey left over, you can extract it to eat or sell. Just make sure that you didn't feed the bees sugar water or use anything like antibiotics, mite treatments, or essential oils that aren't labeled for human consumption. You can feed it back to the bees either way. Your new bees are going to need some food to get started, and there isn't a high risk of Varroa-associated disease from honey. Once you've cleaned out the big piles of bees and tossed out the worst frames, you should be good to go for new bees. Just make sure to keep the drawn comb safe from mice until you can install them. Remember, a colony that is growing big over the summer may also be growing lots of Varroa mites. If left unmanaged, these mites are going to infect your precious winter bees with viruses, and will see the colony go downhill quickly, as you won't have enough healthy winter bees to form a good cluster. In the next 2 sessions, we'll cover how to tell if your bees are in danger, and we'll go over all the tools you can use to keep mite populations from taking over. I hope you can join me. Thanks so much for taking the time to learn with me. Your bees are really going to appreciate your effort, and I hope that it helps make you a happier and more successful beekeeper. I'll have handouts on our new site, keepbeesalive.org, and there will also be ways to stay connected, more videos, listing of hands-on clinics, and other resources. Wishing you all the best to you and your bees.